Hello, y'all. Hey, it's Tim Nutt here, and this is the homework assignment for Lesson 9 in the most excellent Pico W tutorial series by Paul McWhorter. Apologize for not having any videos out in a little while here, a couple weeks. Had a lot of things going on with work and family, but I'm back, and I'll be back doing more on the Arduino as well. But this one is the homework assignment for Lesson 9. I don't want to waste too much time on introduction because there's a lot I want to do in this, so we're going to go a little above and beyond, if you will. We're still keeping it beginner based, using only what has been taught thus far in the tutorial series. But we're going to tie a few things together from a couple lessons into this homework lesson as well. It's kind of add-ons. But the goal for this homework lesson, or the assignment that was given, was using PWM or pulse width modulation, and we're going to ask the user for an input, and then we're going to use that voltage to brighten or dim an LED. So let's get started on that first part, and we switch over to here. Let's start building the circuit. First thing I want to do is you can see there's a few other extra components on here that'll be for a little bit later. And let's see, let me bring up, before I do that, a little pin out there for us. And I'm going to hook up our, I want to go ahead, we'll need it later, so I want to put our positive out, or 3 volts out. It'll be pin 36, which should be number 5 here. And we want to use, that would be pin 38. We'll just establish a ground rail there. And for our LED pin, we're going to use GPIO pin 15. Let's hook into that one there, bring it out so we can get to it. And that should be all we need for the pin out for the moment. That's PWM 7 Bravo. We'll bring this up later when we do some other stuff. First, I want to check, we'll do a little bit of coding before we set the LED up. We'll do a little bit of coding and then test our input with the multimeter. And then we'll put our LED in and see if it works there. So let's go to this screen. And first we need to import a couple things from machine. If I can spell here. Import, we need to import PWM and pin from machine. And we're going to go ahead and import sleep here from time. Import sleep. Alright. Now we need to set up our LED. We're just going to call it LED, and we have that on GPIO pin 15, I believe. Bring up the, yes, GPIO pin 15. Alrighty. Let's see here. So we'll put that on 15. And we'll be setting it up a little different way than we have been recently because we're using the pulse width modulation, not just a pin out high or low. So we need to do LED is equal to PWM, and then that is pin and our pin we have labeled as LED, which is GPI open 15. Close both of those. Now we need to set our frequency, and we'll use what Paul used in 1000. We may play with it a little bit later, but we'll just use that for now. And then we also need to set or establish a variable for duty. Duty, I think yeah, it's lowercase. And we need to unassigned 16-bit, and we'll do that to 0. All right, and then we need, let's set our delay time here. DT is equal to, we use 0.25, be a quarter second. All right, that should set up or start what we need so far in the setup. So let's do our while true, get that set up. Now we need to let's set up what we need or what we're gonna ask for to get our voltage here. So let's go set voltage. That's what we're gonna input. Is equal to, let's do float, and then input, and then let's see, what question do we want to ask? Not double, single quotes, I believe. Let's see here. What voltage would you, if I can actually type tonight, like, close and close. Now we need a formula. Go ahead and put that up here. Let's see if we can kind of see it. I know we'll go to we'll put it here for a minute. Anyway, basically, this is the math. We've got our, make sure you can see it here. Slope action 0 to 3.3, 0 to 65,550. And you can see the math. Paul went over it. I'm not going to go over it too much, but this is the math I used to arrive at this here. So we're going to use that formula. So our be right here is what we're going to put in there. So PWM val is equal to that'd be 65550 divided by 3.3, and then we need to times that by our, I believe our set voltage, I believe. Alright, now let's see if this works. Actually, now we need to do one more. Let's finish setting up the LED first here. So we need the LED. We capital LED. Duty underscore unassigned 16, and that's gonna be int PWM val, and let's print our value so we can see what we're expecting to see here. So we want to print, I believe it's PWM val. I think that's what we're after here. Maybe not. We'll see. It might be set voltage. And anyway, let's move this out the way. And to do this, I'm gonna come off the ground rail there, get a couple leads for our multimeter to see what we have here. Alright, let me get these hooked up, and I'll put the multimeter where you can see it. Clamp on here. There we go. Bring it to voltage. I'm not sure why it's reading half a volt right now, but let's upload and see if we made any errors here. Okay, it asked what voltage we like. Yeah, it goes 0. It must have been something residual from a different one. So say voltage we want is 1, enter, and it's showing 1.014. It's pretty close to 1. Okay, that's our PWM value. That's what I thought we needed to set print set voltage. Because we don't need to. Well, that could be useful for debugging as well if we were trying to do something else in that slope. But anyway, let's do that there. Let's try this again. 1, reading 1.0, 1.5, 1.522. Let's see, 2 volts. Oh, I guess we should be in the proper scale there. And 3.3. Okay, good. So we're getting what we're after there. So now, let's go ahead and turn this off. Just go ahead and switch it back to 0 for now. And we'll take these out of there and put our LED and current limiting resistor in. And we will make sure it works on the LED here. So remember, long leg towards your positive. Put that there. And since I established the ground rail up here, put that there. That should work. So now, what voltage would you like? Let's do 0.25 volts. Okay, we see the LED started to light. Say 0.5, it's a little brighter. 0.75, gets a little brighter. And 1, see, it's flickering in the camera. Okay, that's why we never did our sleep. See if that'll take care of the flicker, so it's not refreshing over and over and over. It's quite so fast. Alright, let's try this again. I think we were on 1 volt. Nah, it still shows the flicker. It must just be the frame rate. But anyway, and let's go to 1.5. Gets brighter. 2, it's brighter yet. Should be max brightness. There, we can see it down there. And back to 1, 0, goes completely out. 0.1, just barely trying to illuminate there. Alright, so that was basically the homework. Let's go a step further here. Actually, we'll go a couple steps further, but just one step at a time. Why don't we create, let me go back to the circuit build here. Why don't we create a, let's try to get this out of the way a little bit where we can still see it. Alright, there we go. Why don't we set up a warning system for when we're adjusting our voltages here? Well, let me line these up, let me get these put in first. Now I want to use, so green, we'll use GPIO pin 2, just on number 4 here. Let's put that in here. We'll set up a warning, and using our if statements there, to light up a green, a yellow, and a red LED, depending on what voltage we are. Maybe certain voltage is too much. Maybe we're not just lighting an LED. Maybe we want to control the fan or motor or whatever we're using with the PWM there. So let's see, and I think GPL pin 5, which is physical pin 7. Try to get it where it's kind of neat and organized here. Set up and get in there. Oh, you're gonna be a pain. Let me straighten the end of this out here real quick. Alright, that was physical pin 7. There, that went a little better. I'm sorry, I know my big paws are in the way of seeing there. And then red will be hooked to GPIO pin 7, which is physical pin 10. So let's go 10, see if we can get it in there nice. To there. Alright, so now our green LED says that's green, so it's going to be in this column, long leg toward the positive. Alright, set our green, and then our yellow, sure, long leg toward the positive still, and our red, all spaced out nice and evenly-ish there. Alright, now let's put our current limiting resistor in here. Ground. Why is... I don't know why green is lit up. That is weird. I don't think it could be residual from the other one, but... let's... I think we got it hit up. Really not sure why. Green would be lit up, but... Alright, let's go Stop that. There shouldn't be anything coming out of there. Not catching voltage or connecting from anything, but ground. Yeah, I don't know why the green LED's lit up, but I don't have anything crossed on the positive rail, do I? No. That is weird. Might be residual from when I was playing with it earlier. Not even set up, so it shouldn't be, but anyway. Alright, so now that's the there. We can go ahead and we'll leave that up for now. Let's go back to this other screen where we can see the code, because we got to change do a little bit more coding here. Alright, so if we want, let's use our sleep down here a little bit. So now we need a if statement. So let's do if, actually let's come down a little, if, now if our set voltage, let's say if it's less than 1.5, let's say less than 1.5, I like add spaces there just because it's if set voltage is less than 1.5, we almost forgot our parentheses. Actually, let's go a step further first. If set voltage is equals 0, we're going to keep it up everything off. Nope. So let's do, well, actually we need to, before we even do that, we need to identify our LEDs again, or up here. So let's just do green is equal to, let's see, what pin did I have that on? Green is on 2. So we do parentheses, and then right? Pin, yeah, there we go. 2, output, okay, green was on 2, and yellow is equal to pin, that was on 5, WT, and red is equal to pin, excuse me, now we had that on GPIO pin 7, nope, not a capital I, and OUT, excuse me. Alright, so now we got that. We're going to say green value is 0. We're going to have everything off, so yellow dot value is 0, and red dot value, oh, not a capital V, back over where it's supposed to be here. There we go. Alright, let's see if that works first so we can, right there. Now what voltage would you like? 0. Alright, good. So that turned it off. Alright. So let's copy this, Control C. And paste. I really like spaces. Let's do this again here. Give us a little there. So set voltage. And now on the second one, actually we're going to need that sort of 4 times. Oh, there we go. Alright, so if set voltage is, this one, if set voltage is less than 1.5, say if it's less than 1.5, we'll have the, okay, actually, since we were doing 0, since 0 is less than, this actually goes back to 6, we need to make sure to not have any overlaps. So, to do this, if set voltage is greater than 0, need our parentheses, and set voltage, if set voltage is greater than 0, and set voltage is less than 1.5, we're going to have the green LED on. So now if set voltage is greater than or equal to, greater than or equal to 1.5, because here we went, it's greater than 0 and less than 1.5, so that was up to 1.4999999, but it's not including 1.5. So now we're greater than or equal to 1.5, so we're including that. Now we need to go and set voltage is, let's just say less than, we'll go, say 2.5, 2.3, that'll work. Then we want the green off, we want the yellow LED on. Alright. Yes, and if set voltage is going to be greater than, oh, that's less than, greater than or equal to 2.3, because we didn't equal, up to 2.3, we didn't include it. We want the red LED to be on. Now let's make sure we got it. If it's 0, all of them are off. If it's greater than 0 and less than 1.5, we turn the green one on. If it's greater than or equal to 1.5 and is less than 2.3, we turn the yellow one on, and the green and the red are off. If set voltage is greater than or equal to 2.3, we turn the red one on. So then let's go ahead and alright. So now what voltage we want? Let's just say 1 volt. So 1 volt, the green's on. Let's go down to 0 or 0.01. It's almost off. Actually, we can, we don't need to print this set voltage anymore. Let's just do that there. Taking up. So, alright, what voltage would we like? We want 0. All the lights are off. 0.5. Green one's on. It's coming up a little bit. Let's bring it up to 1 volt. Just a little more. 1.4. It's a little brighter. Now 1.5. And there it goes. The green one off, the yellow one on. That's good. Let's bring it up to 2. You notice our LED is getting brighter and brighter still. Now say we want 2.29. 2.29. It's still less than 2.3. We go 2.3. And the red LED comes on. And let's just go up 3.3. The LED's at its max. And we want 0 volts. Everything goes off. There we go. So that is working. Now there's one other thing that I would like to try to incorporate into here. I apologize for the video being long. It's already 30 minutes. It's almost as long as the lesson itself, but I'm having fun and I hope y'all are too. So let's go back to this and let's add a potentiometer. Maybe we don't have a maybe there's not a screen or keyboard around, and actually we need a different pin out, because this isn't showing us our there we go. Should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll use ADC 0, GPL pin 26. So maybe, just maybe, you don't have a keyboard or a screen to see what you're doing, but you do have a potentiometer. And since you do not have a screen, you need these warning LEDs to tell you whether you're past certain parameters or not. So we'll use our same if statements. We'll just have to change a few things. So to get this set up here, we need to take 2 pins over. Oh, if it go in there instead of falling over. Alright, put our ground. Now you know why we needed the positive volts on the to come off there, because we need to set our have voltage for a potentiometer here. Oop. That in there, right? Guess so. Alright. Alright, so now that that's hooked up, we need to redo some code. So we're going to keep our if statements. We don't need the string anymore. So for now, I'll just we'll click on it and comment it out, because we don't necessarily need it, but if we decide to go back to it later, it's still there. But we do need to add some other, and for this part, is this it? Yes. Right here, and I'm not going to go through it all. But this is the math to go from 3.3 to 0 and 0 to 65535. Make sure you can actually see it here. That's where we go on. This is our line and slope rafter. And this is the math that I used to get to it. And this is the formula we'll be using in here. But first, we need to set up our which we did. Okay, yeah, we did set those up. We got to set our pop pin up. Pop pin is equal to 26, I believe. Yes, GPL pin 26. And then we also need to set our tell it it's analog to digital control. So that is pot is equal to machine dot ADC. I think it's all capitals. We'll find out here in a minute. Anyway, and that is pot pin. Oh, pot pin that we're reading that from. So pot equals machine ADC pot pin. All right. So now down here, I think that's all we need up here. Alright, so we're not getting our input. We already commented out we're getting our input, but we still need this formula, I believe, and Lady Duty to tell it what to do. But now we need to get our set up to get our reading from our potentiometer. I'll leave this here so I can plug that formula in, and I'll move it away from it. So our pot valve is, we need to tell it where we're reading it from. So equal pot dot read underscore unassigned 16, and we'll just leave that. I believe that's yeah. I believe we just leave those empty there. Alright, now our we want to, because we're looking for set voltage down here, so we're going to still call it set voltage. Set voltage is equal to, alright, now I need to plug the formula in, is equal to 3.3 divided by 65119. No, I said 199. Okay. 199. And then multiply that by pot val. And then we need to subtract. And then the next one was 336 times 3.3. I think I'm doing this formula right. Divided by 65119. No, 199. Why do I keep saying 99? Probably because it's 1:30, almost 2 in the morning here. Alright, I think that's right. Let's see, 3.3 divided by 65199 times pot val minus 336 times 3.3 divided by 65199 Alright, let's see if we did it right. Okay. Okay, well let's bring our print back here. So let's come down here to see, because we got our green on, so it might not be reading 0. Print, set voltage. Let's run that again. Okay, so it's not reading exactly 0, even though we're all the way down. Let's see if we can set voltage. Set voltage, PWM bell. Let's see if this is working first. Alright, it's getting a little brighter. Getting a little brighter. Let's see, once we go up of 1.5, should change to yellow. There we go. And up a little more. Once we get up over 2.3, it goes to red. As the LED is getting brighter and brighter. Now we're reading 3.3 there. And let's drop it down. We're down below 2.3, goes to yellow. Now down below 1.5. Let's see how close we can get it there. Get right on the cusp. Just over 1.5. Yep, it goes down. LED's getting dimmer. There we go. Yeah, it's still reading. I might be able to, actually, if we set voltage, how would we, we haven't got into rounding and decimal points and everything yet, so I'm not going to go into there. There's a way we could go in and get that to not show all that. But that's, I've already, it's already over 40 minutes, and I apologize, but I think we had fun. I hope y'all did too, and may learn something. I know it went a little beyond the homework assignment, but I just figured it'd be good to kind of tie this homework assignment in with some of the things we've learned already before. And so with that being said, I hope everyone has an awesome day, night, evening, morning, afternoon, whatever whatever time you're watching this. And we will catch y'all next time. Thank you for watching. Bye.